side is another rectangle. That's kind of that first back side here. And it's got a height of 7, but its length here, and let me color code this because I think that'll really help here. Its length is this and this. That's the backside. Does that help see it?
Yes.
So it ends up being 7, 5 plus 2. Maybe I should even show that. Then there's this kind of this,
that whole back side is 7 because of the, yeah.
yeah. Okay. And then there's kind of this keep going around like the other side of the building. There's yet another backside. So I got to draw yet another rectangle. And I'll try again to color code this. It's this and this gets you down there, which is 4 plus 2. Height is still 7. Okay, but wait, there's more. There's the L shape top, and there's 2 of those. Before you start sectioning it off, I probably would just label it without trying to do anything weird yet. But there's 2 of those.
Okay.
Okay, so the L-shaped one, you got to decide where you're going to cut it. Do you see the cut as being vertical or horizontal or both? Do you have a preference?
Probably horizontal.
Horizontal, okay. So from there, you've got a 2x4, and then you really don't need this dimension anymore, except you need it for the, you need it for the long length there, which is 5 plus 2 equals 7.
All right.
So I know this is a fair amount of work to do all this, but you are literally just adding these numbers when you're all done. It's not like rocket science, I'll say. It's just doing it. So the first one, you have 2 of the 7x2s, that's 14. Plus the next one is 4x7. Plus the 5x7. The next one is 7 times 7, 49. Plus 6 times 7, 42. Plus the last one is 2 times. So the first one down here is 8. This one is 14. 8 plus 14 is 22. And you have 2 of them there.
Okay.
The other reason to do it this way, which we need to get this number here, but I want to make this point before we get the final answer, because then we're kind of done, feel like we're done, is if it wanted the lateral area, this top row is the lateral area. The lateral excludes the thing that it sits on.
Yeah.
You think of it as the floor and the ceiling, all right, so we do need this number. I'll get my calculator out. Recommend you check as well, since I am 49, 42. All right, what do you got for me? Whenever you get it.
226.
Yes, and then we're looking for units squared if you don't have units, but and you don't have units. So all right, so some students really like this section. They're like, kind of out of the proofs for sure. It's stuff you kind of can see. Depends if you're more visual, I'll say.
Okay.
All right, problem 9.
Yes.
All right, lateral area and the total area. So basically what I just said, you got to find the area of the stuff that is not on the bottom and the top. You're supposed to know that the base is the thing that it sits on, but you might say, well, couldn't it sit on any of these faces? And you're right. So the bases have to be parallel. They have to be parallel here.
Yes.
Okay. That's another thing to consider. All right. We do have to make a few little assumptions, because I don't know visually if these are 90-degree angles kind of right in there for the triangles. I want to say that they are, but
Yeah, if it says right prism, then I think she said that means that those have a
yeah,
right.
it's drawn not well, but
Yeah.
that is helpful. Yeah, if it were a test, maybe I'd go up and say, hey, can I assume this? Sometimes you can read their body language to get the answer. All right, so the first one I see is there's this 11 by 13, but there's actually two of them. There's this one on the left and this one on the right. So I would put like a ×2 designator in there, or somehow indicate that there's two of them if you like tick marks or something else like that. There's then, if you kind of go around to this backside, there's another one of these, which is height is 11. The vertical height is 11, and then it's 15 width. And then you go to the left and you notice, oh, it's height is 11 and width is 15. So there's actually two of those.
Okay.
So that takes care of the lateral area. 1, 2, 1 in the back, 3, 1 to keep going, 4, 2, and 4. That takes care of the lateral area. The total area now, you're going to have to add to it the top and the bottom. And this is where it gets more difficult, because the top and the bottom are triangles. Oh wait, they're giving you that number down there. I didn't realize they're giving you that number. It's bothersome though. It's bothersome that this is the 4, 13, 4, 15. So that's not a right triangle, which
Yeah.
suggests we have to do something else. Plus, it's a problem set C, so I can't assume anything. I'm struggling here to see how this is drawn, but
Maybe it's talking about the right, like the angles that are right are the ones on the parallelograms, or the ones on the squares.
yes, and that's where I think we're going to have some issues here with this. So it's 13 and 4 and 15. Okay. So having said all that, there's a few things we can do here. Like it's not a lost cause or anything like that. All of the triangles are the same.
Yes.
Okay. So we know that, and so we need to say, okay, there's 4 triangles of 4, 13, 15, like that. So when we don't know that it's a right triangle, we have to use, we talked about this last week, Huron's formula.
Yes.
Okay, so that the first thing is you find is what's called the half perimeter. So we got 15 plus 13 plus 4 divided by 2.
Yes.
So 16. And then from here, the area of one triangle is the square root of the half perimeter. And then you subtract each side length from the half perimeter.
Okay.
So this is 1, 12, and 3. And wouldn't you know it, that works out nicely. Wow. Okay. So this ends up being the square root of 16 times 36. Square root of 16 is 4. Square root of 36 is 6. Ends up being 24 for that. But you have 4 of them, so don't forget that part. So the triangle is 24. We'll come back to this because we probably should have calculated these other ones first. 11 times 13 times 2, and then 11 times 15 times 2. Yes. So let's do that, and then we'll add in 4 times 24 for the rest of it.
Okay. Yeah, that makes sense.
So I'm going to the calculator here. All right, so the first one is 286 plus 15 times 11 times 2. That's 330. So you add those together and you get 616 units squared for the lateral area. Think of painting the walls, that's what that is. And then the total area, you got to add the top and the bottom, which is this 4 times 24, which is 96. So the total area is the 616 plus the 96.
Okay.
Do you need me to scroll down to show you any of the other parts of this problem, or do you have it all down?
All right, I got it. Thank you.
You got it. Okay. All right. So what would be next?
Okay, let me look at the other one that I had an issue with. All right, number one, A, B, and C.
Yes. We're going to give you one problem, but we'll call it 3 parts. Might as well give you 3 separate problems.
I know.
This and this. All right. So 1A, one of the advantages of this digital platform we're on is I can redraw it each time. I know that would be a pain for you, but that really would be very helpful to see this each time is this. So I'll redraw it for each one. So first thing is to find the total surface area, and you don't have to differentiate between the lateral. So there is a shortcut here. You'll see that when you do a bunch of these in a row. But you have the HW first, the 10 and the 5. You've got 2 of those, front and back. Plus you have the side, which is 15 and 10. Okay, so we did the front and the back, and now we're doing the right side and the left side. And then you do the floors. I don't worry so much about getting it to scale. It's more about just knowing that you've checked the boxes on everything. Now there's like I said, there's a shortcut here. This is HW, this is WL, and this is HL. And there's 2 of them. So the shortcut for a prism, and I mean, I would never tell you to memorize this, but it is the shortcut, is this formula right here. Sorry, not the volume, the surface area.
Okay.
After you do a few of these, you're like, maybe I can just pattern it, and that is the case here. So 100 plus 300 plus 150. And you get your answer there, 550 centimeters squared.
All right.
All right, so let's do B next. All right, so the length is 12, the width is 7, and the height is 3. Do you want to try working this one out on your own, please?
Sure. Yeah. Okay, I got 282.
That is correct. And then units on this one, I think it's in millimeters. So you'd go millimeters squared. So for the last
Okay.
one, why don't you just use the formula here for this, just to shorten it up. I'm sure you've either got other problems or other things you might want to do tonight, but yeah, you don't want to remember this formula. It's just that it does come out of it. So let me get those values. Of course, there it is. Okay. And you can mess up L, W, and H. Like the order doesn't really matter either. You just have to, isn't there? So same thing here. Give that a try and let me know what you come up with.
Okay, I got 810.
Yes, that is perfect. All right. Okay, so that takes care of that units on that one. I think it was inches squared. So
Okay, all right, I have just one more.
yeah, sounds good. The music in the background doesn't bother me. If notice you keep muting yourself, but whatever's best for you. Happy to.
Yeah, my dad's just clinking around on the piano.
All right, yeah, I'll get the copyright infringement from YouTube here shortly.
Beethoven.
Yes, they'll say you're trying to monopolize, monetize. You're like, no, just. All right, so yeah, let me know the next question. You can also drop in the chat if you don't want to keep muting and unmuting.
Okay, it should be 6B.
Okay. 6B. The cheese slice here. All right. Open top. Okay. What is the total area of the prism? Total area of the pieces of cardboard needed to construct each open box shown. They're telling you to forget about the top, that there's only a bottom. There are some bunch of faces to consider as well. So probably best to kind of look at the faces. So there's this one on the left, which is 6 by 8. And then there's the one on the right, which we don't know. Okay. It's like, well, how are we going to do this? We know that it's 8, but how do we find, now I'm going to go ahead and highlight that. How do we find this one right here, which is that edge there? I really recommend, maybe considering at least a colored, colored pencils or highlighters, something, especially in this course, to like denote things in your notes might help. But it is a 30, 60, 90 triangle. So let's go ahead and draw the 30, 60, 90 triangle. And we know that this is 6, this is 60, this is 30. Do you remember from last time how to find the other sides given this information?
Yeah, yeah. So if that's is 6 the short leg?
It's across from the 30, so yes, it is the short leg.
Okay, so if 6 is the short leg, then that means 6 is X.
Okay,
so the hypotenuse, which isn't the side we're looking for, but that would be 12, and then the side that we are looking for, or wait, is that the one we're looking for?
We do need 12, but not quite yet. We were looking for just the yellow one, and all.
The yellow one should be 6√3 then.
Yeah, so it's not great, but it is, that's the yellow one. 6√3. Okay, so that's enough for that. And then we care about the back face. So we've got, yet another rectangle. Its top is 12. That's, let me highlight that in case you go back. Like, how did he get 12? Right there. And then the height is 8 on that. And then there's only one triangle because it's an open top.
Mm-hmm.
So
Okay.
you don't have to you don't have to like double the area here, but you need to find the area of each of these. So a little bit of work here. The first one is 48. The second one is 48 square root of 3. The rectangle is 96. And then the last one, 1/2 base times height. So that ends up being 18 square root 3. So just a tiny bit of simplifying. So we have 18 square root 3 plus the 48 square root 3. That's 66 square root 3.
Yeah.
And then you get the 48 plus the 96. That's 144. No units this time, so we'll just say units squared.
Okay, cool. Thank you.
Yeah, you're welcome. Do you like this part of the course? Is this better, easier, getting easier?
Yeah.
Okay.
Yeah.
All right.
We like, especially the last one too, with like areas and all that. That's
Yes.
like one of the better times I've done on tests. I
Good.
just hate proofs so much.
Yes. And you can see chapter 12 is surface area and volume, a lot of numerical problems, you're going to get numbers as an answer, more specificity in your answers. So, you're trending in the right direction, we'll say, for this course. All right. Are there some other questions that you would like answered this evening?
Those were the only ones that I had. Today's like lesson was pretty easy. So
we do have some time left. I mean, you are the customer. I'm happy to preview upcoming sections, SAT prep. I mean, up to you. We can end early. It's totally up to you. You are the customer. You tell me what would be best.
could you like preview some like upcoming things, like maybe like 12.3? I know we're gonna do that tomorrow, so if I could like have a head start on that, I think that would be beneficial.
Yeah. Do you know which problems you might get for homework? Or do they not tell you until the day
No,
of?
she just tells us. Actually, let me see if she's posted the assignment yet. She might not have, but she might have. Okay, no, she hasn't posted it yet, so I won't know until tomorrow. But if you just like go over generally like what
Well,
it's
we'll
gonna
just
be
do some
about.
problems. I mean, that's the best way to use the time. You're going to have these for homework. You can either look back at your notes or redo it. Up to you. But yeah, what I'm going to do right now is looking for a really good reference sheet. I had found one I really liked. Let me see if I can find it. I'm on a different machine than usual. These are all awful. Okay. This is the one I wanted. All right, I'm gonna drop this in the chat. It's one page. There's a lot of reference sheets that you might have. I think this one applies though to what we're doing in this problem. All right, so let's go just go right to number 1. We'll just start working from there and start. Okay. What is the total area of a sphere having a radius of 7? So again, your book's a little old. We don't really say it, so it should say surface area or lateral area, but there is a formula in that reference sheet I just sent you for that. The more math you take, the more you're like, I need some formulas here. So for a sphere, And this is a good question to ask your teacher. Will you need to memorize the formulas?
Probably.
Probably. Yeah. So, you could beg, right? You go in there and say, oh, look, it's a handy reference sheet. We'll wash the car. We'll bring you, donuts. The formulas are the hardest part of this. It's really hard
Yeah.
to memorize these because they don't really mean anything. You're like, well, and when you take calculus, if you do, you will understand the relationship between these two, but it's a couple years away. So the surface area, the total area of the sphere is a 4 pi 7 squared. So 49 times 4, 196 pi in this problem here. All right,
Okay.
so you can see that B, C, and D are very similar. C and D, they give you the diameter. So why don't I have you try D on your own? No, C, have you try C. So you have to convert that to radius.
Okay. I'm just gonna, you just want me to find the total area?
Yeah, just total area, not make it too complicated here.
$144 pi.
Diameter is 6. What is the radius?
3.
Okay, so 4 pi 3 squared. You square before you multiply. You want to try your answer one more time?
Be 36 pi.
Yes, 36 pi. Thank you. It's easy to write something down that isn't right and not really know because you can't touch it. You're not really sure how much the area actually is, but we'll, all right, so we're gonna look at 2A next. And the instructions say to add or find the lateral area and then the surface area. And this is a cone, the party hat. Let's see if we've got a formula for that. We do. Can't emphasize enough how important having the formulas really are here. So you may want to start early memorizing them, pick a, 1 or 2 a day, then you'll know them all in a week or two. For the cone, you might know the volume formula from a previous class or just that the ones look kind of intuitive, but the surface area and the lateral area are not intuitive at all. So the lateral area is pi rs. And you're like, what's this S? S is the slant height. It's the distance along the outer edge there. All right.
Okay.
So in your problem, to find the lateral area here, it's pi times 3 times 8, which is 24 pi. The surface area or the total area is pi r squared plus pi r s. You have both of those now. You have the raised pi 3 squared, pi times 3 times 8. Basically, you're adding in the base to the lateral area. Pi r squared is the base. So you're adding that part to what you just calculated.
Okay.
So all of the surface area formulas have the lateral area inside of them. So one way to memorize these or remember these is to remember the surface area only and cut out the part that isn't needed for the lateral area. That way you don't have to remember both formulas. 9 pi plus 24 pi equals 33 pi.
Okay.
All right, so why don't I have you try D here? Bring the formulas down. All right, so I want you to find the lateral area and then the total area for us, please.
Okay. That's a 1, right?
It is 1, yeah. Really grainy.
Okay, so for the lateral area, I got 3 pi.
Okay,
And then for the surface area, I got 4 pi.
right. Very good. Now, what you can, maybe you can see here that you're not going to get a problem like this. You're going to get a problem where they give you maybe like they tell you this is 10 and this is 8, and you've got to find S. Okay, so all the stuff you learned with triangles will still apply here.
Okay.
All right. All right, we should do B and C. I mean, it's very much like if you got the formulas, you can do it here. This is a cylinder. I'm sure you know that. The cylinder has more formulas. We'll grab the cylinder formulas. So they introduce kind of these new letters. You saw that in the last problem, the S. Some books use L. I should have said that. Some books you will see that this is L instead of S. But you can check with your teacher what they want, what you're okay to use with. So for cylinders are pretty nice. The surface area is 2 pi r squared. That's the bottom and that's the top. The lateral area is 2 pi r h. H is the height. These are the most straightforward because you can kind of see everything that's going on. 2 pi, radius is 7, height of 10. Okay, that's 140 pi. Surface area is always that number you just calculated plus the other stuff. So in this case, it's pi r squared, pi 7 squared, but you've got 2 of them. You got the top and the bottom. So that's 98 pi plus 140 pi. That's 238 pi.
Okay. Let me write those formulas down really quick.
Yeah, I did drop that in the chat as a reference sheet. If you
Okay, thank you.
want to get that.
Okay. All right.
Okay, so let's move to like a more appropriate problem that you might see here. Let's go to, yeah, we kind of reference this here. Let's go to a 7C next. So you know enough to find the total area of this one. I can bring down the formulas if I need, but will you attempt to solve this for the total area? And you do need the slant height.
Okay. Yes, I can do that.
All right.
Okay, I got 480 pi.
480 pi. What did you come up with for the radius
15,
and the slant height?
17.
Good. So that's a Pythagorean triple. I don't know if you did Pythagorean theorem, but because they're nice whole numbers, it's one of those that they hope you will see. And believe it's just pi r L, right? So pi 15 times 17.
Yes.
Okay.
Yes.
your result seems a little large. What am I missing?
Let me look. Oh, that's 255 pi in
Yes.
itself. And
Okay,
then
but then you added, okay, now I know what you did. You of course added the base,
mhm,
which is 15 squared, pi 15 squared. Okay, that is 480 pi. Very good.
okay.
All right. Okay. This is 4B. If I asked you for the total area, do you think that it includes the circular section down here?
Total area, yeah. Just like that base, that circle
The,
base.
the not just it, but does it like it is that part of it?
Yes.
It is. What if I asked you about lateral area? Is that circular part?
No.
No. Good. Okay. So that's a key distinction about being able to do this part of the course. Now, I think I threw up the formula um, for the surface area of a sphere, total area of a sphere. It's 4 pi r squared, but that's if you have a whole sphere. This is not a whole sphere. This is half a sphere. So you have to know to cut it in half.
Okay.
And then the total area is 2 pi r squared, the lateral area, plus the area of the base. So some books formula sheets will actually combine those together, but you don't have to. You can just look at them as separate things and then add them together.
Okay.
Okay, so just it depends on the problem, lots of things that you can do to make this easier or difficult. All right, so let's move to 6.
Okay.
6 here. Since we don't know whether you're going to get assigned these problems, sometimes it's not even worth doing the calculations until you get there. All right, find the total, including the rectangular face surface area of a half cylinder with radius of 5 and a height of 2. This might be a good problem to draw out the faces of again. There's that one in the front. And there's 2 of them, front and back. There's the rectangular top. And then there's the, I don't know, the rounded label that ends up being another rectangle there. So being able to draw them, that might help you with kind of missing ones that we're talking about earlier. The first one here, what is the top dimension here all the way across?
That would be 10.
That'd be 10. What else do we really need for this to find the area of it? Is that enough knowing the diameter?
We should know the radius.
Yes, so we actually don't need to know this. We need to know the radius of this thing is 5. Okay. And then it's a circle, but it's a half circle. So it's 1/2 pi r squared. But because you have 2 of them, this is where you got to be careful. Like, do you want to carry out the multiplication by 2 now or wait until the end? You got to be careful that you're going to undo the 1/2, but be careful that you don't forget to either include it or not include it. Okay, so we got enough for that. For this top one here, what's the base and the height, or the length and the width?
Okay, so the length would be 10.
Okay, good.
And then the width would be 2.
Good. And then not drawn to scale, but do you know either of these dimensions?
For which one?
The one on the right, the one that kind of the goes
This
down.
one?
Yeah.
We know the 2.
2, good.
But we don't know the other one.
So again, sometimes it's good to kind of highlight it and be like, all right, well, that's this. What is that? Like, what's another name for this highlighted piece?
An arc.
It's an arc. It's a more specific. That's like we got a little more specific and we get even more specific. So what if I kept drawing this? What is this in red?
In red, that would be the circumference.
Circumference. So it's like half the circumference. So the circumference is 2 pi r, but we only want half of it.
That's the same as pi times the diameter also, right?
Yes, or pi times the diameter, but you want half of it. So just
All right.
it's easy to kind of be off by 2 in any direction here. So we've got that. We know the radius is 5. So we're really set here. The surface area of this whole thing is 2 times 1/2 pi 5 squared plus 20 plus, and this is where you got to decide, okay, am I taking half here and it's pi r and then I'm multiplying by 2, or am I going to take 2 times 1/2, which is 1, and then it's 2 pi r. However you do it, just don't have an extra 1/2 or extra 2. And now you've got it. So this becomes 25 pi plus 20 plus 10 pi, 35 pi plus 20.
All right.
Just to summarize, close out, I really recommend trying to draw the little pieces if you can. That might help you going forward. But that is it for us for